All right, welcome back, everybody. We got another TLC call. Today, we're going to be talking with Lukas Vermeer about sample ratio mismatch, what it is, why you should worry about it, and hopefully some tips and tricks on how you can not progress your slide forward. Great. How you can control for it. Hold, please. Oh, there we go.
I like how the backup plan is already failing.
I know, right? The backup, what were we in? We were in like backup plan D. That always makes you feel real confident.
Yeah.
There we go. Meet Lukas. Hopefully he does
hello.
Introduction. Yeah, there you are. He is the director of experimentation at Booking. He's been interviewed by people all over the place, a whole bunch of Harvard Business Review articles that I personally have learned a lot from, and he's a frequent presenter on pretty much every experimentation conference out there. He helps broaden everyone's thinking about experimentation. So I've been trying to get him on the TLC for almost 2 years now, but he's busy and important, which we get. So thank you.
Been that long? Wow. I'm sorry.
It's been a bit, but it's totally fine. We get it. Unfortunately, we do have a tiny technical challenge today. So I'm going to be progressing slides for Lukas. So I want to apologize in advance if there's any sluggishness there, but I'm sure you all can forgive me and him. So I'm going to pass it over to you, except only to talk, because I will keep the slide share.
Oh.
Take it away.
Hello. Can you hear me and see me?
Yes, sir.
Well, hearing was sufficient. And is this, are you making this full screen or not? Is this good enough? Don't know if that works.
If that works for you guys.
Does it let you?
It does not.
This is fine.
Okay.
Okay. Well, so today I'm Lukas. I'm director of experimentation. What that technically means is that within Booking.com, we have about 2,000 plus people that are running experiments, and we've been doing that for about 15 years now. And they use an in-house built platform that we call Experiment Tool. And we built in-house because there was literally nothing available really online at the time. And so we've been building our own since then. And so my group is responsible for that platform as well as the support that comes with it. So you can think of us as sort of the in-house VWO or in-house conductrix, if you will, of Booking.com. And besides that, of course, I also have an external facing role for my group within Booking, where I work with different parts of the organization, trying to figure out where the product is going so that we can figure out what the experiment tool needs to support going forward. Today, I don't want to talk about Booking.com at all. I want to talk about something very, very niche and statistical, but the one neat trick to run better experiments that I think is actually useful for everyone who runs experiments. It's not a silver bullet. I'll give you that caveat up front. It's not the be all and end all of running proper experiments. There's a lot more to it, but I do think this is such a simple method to test for a wide range of data quality issues that really anyone can do, regardless of how much control you have over your experiment platform. And I really see no reason for anyone not to do this. I've done this talk at a conference one time before, and there I would ask the audience when I started, I asked them who has heard of sample ratio mismatch before, because that's the spoilers. That's the one neat trick I want to talk about, sample ratio mismatch. And I asked who's heard of it, and only very few hands went up. And I'm hoping that was a year ago. I'm hoping that that's changed a little bit. Ton says, I know that conference. Yes, Ton, that was your conference. It was Conversion Hotel. I totally recommend going. And so I asked who knows, and very few people knew. I think in the last year I've seen that change a little bit. I think more and more people are aware that this is a problem, but not enough. I think everyone should be aware of a sample ratio mismatch. But then I asked an important follow-up question, because I asked that same audience of the people who are aware of what sample ratio mismatch is, who has seen it in practice, who has been confronted with this problem, and pretty much every single hand that had gone up for the first question also went up for the second question. So the people who were aware of this risk to their data quality also had seen that in practice. So this is definitely not a hypothetical problem. It's very real.
So it's like coronavirus. If you don't test for it, you don't have it.
Yeah, exactly. Oh, you're spoiling my slides. Yeah. So this is something where as soon as people start testing for it, they start finding it. So let's talk a little about the structure of this talk. I have 5 questions on the next slide that I think I want to address. First, why should we care, right? You're talking about sample mismatch, but why should I, as an experimenter, even care about this particular thing? Then second, how will we know that sample ratio mismatch has occurred? How do we know that we're actually encountering this problem? Then third, how prevalent is this? Does anyone have this problem or not? Well, like I said, I think everyone who starts looking for it will encounter it. But we have some other data sources also that gives us a sense of how prevalent this is. Then fourth, what actually causes this? What are the reasons that SRM occurs in the first place? And then fifth, what can we do about it? So I hope that by question number 5, you're I'm sufficiently convinced that you think that this is a problem, that we should do something about it. So I want to address that at the end as well. But first, why should we care, right? And to explain why this is a problem, I want to use one of my favorite papers ever. It was called The Pitfalls of Experimenting on the Web. It is a paper written by 2 statisticians that tries to point out data problems in psychology papers. And because these are statisticians, obviously they have some math in there, but because they wanted to explain this in more understandable terms for psychologists, they also wanted to include some practical examples of why this is a problem. This is one of the reasons this is my favorite paper. So if you go to the next slide, I've highlighted part of the abstract here. I can send links to the paper later. But essentially, they try to draw, on purpose, they try to draw mind-boggling yet false conclusions. For example, that imagining applying eyeliner leads to weight loss. So I'll let that sink in for a minute. Applying eyeliner, so thinking about how you apply, I don't know, is eyeliner the one where you draw with a pen, or is it the one with the brush?
The pen.
The pen, okay, yeah, so the one with the pen. So thinking about putting that on, makes you lose weight. And they actually have some evidence for that in the next slide, because if in table 2, they have experiment B, can imagining applying eyeliner help one lose weight, where the control condition is describing how applying versus not applying eyeliner would make one feel differently. So this is a survey online where they ask people, please tell us how you would feel about applying eyeliner. And in the treatment condition, so the B in this experiment, they asked in the survey, describe how applying versus not applying aftershave cream would make you feel differently. Now, so the only difference between these two is they're both online surveys where people can answer questions for a small amount. I think they're using Mechanical Turk or some similar tool. And the only difference is the question between these two questions is whether you're applying eyeliner or whether you're applying aftershave cream. And then if you highlight the results, you can see that the reported body weight is in pounds. Obols, I don't know, what is this? This is not metric. So I had to ask Google, and it's like 82 kilos versus 72 kilos, I think. So it's a pretty, like, that's a 10 kilogram, or what was that in whatever you're using? 20 pound
22
weight.
22 pounds.
Yeah, 22 pounds weight reduction between those two groups, which in most diet programs, that would actually be considered a reasonably effective diet. And this difference is also statistically significant. So I think I'll go into the dieting business and just start my own company, recommending that people follow this amazing diet where you don't actually have to change anything about the way you eat, and you just think about eyeliner every morning. I've been doing it for a while now, and it's really doing me a lot of good. Clearly that can be the case, right? Clearly this is one of those mind-boggling yet obviously false conclusions that were drawn based on the data. And if you go back to if you go down to the next slide.
The next one.
Sorry to make your life difficult, Kelly.
No.
So I've actually highlighted this part where they say, in experiment 2B, we predicted that an experiment that assigns participants to imagine applying eyeliner would end up with a sample that is disproportionately female. Now, what's going on here is that this is a survey where people fill out a bunch of questions, and at the end of the survey, they get a reward. But the reward is relatively small, right? They get only a small monetary value. They get a bunch of cents for answering the survey. And what they predicted was that if you ask men to think about applying eyeliner, there's two responses. One, they can actually do the task, or they could say, screw this, I'm going to do something else. And so they predicted that more men would drop out when asked about this question, where they don't even know whether it's a brush or a pen. And that the result of that would be that the sample that remains is disproportionately female. There are more women left in this group. And as a result, participants assigned to Imagine Eyeliner would report weighing less than those assigned to applying aftershave. That's not because they're imagining something different, but that's because women on average weigh less than men. And they actually see this back in the data. So this prediction is actually borne out if you go to the next slide, because if you look at the dropout rates that they also report, you can see that the dropout rate for the aftershave condition is about 24%, whereas for the eyeliner condition, it's 32%. Again, that's a significant difference. And it's likely that that additional dropout is disproportionately male, which explains the change in body weight. Now, if you don't think that this is a problem, right? If you think it's fine to draw the conclusion that thinking about applying eyeliner makes you lose weight, and you want to build your business on things that you learn this way. For example, you want to start a weight loss business where you recommend this to your clients, then you can drop off right now. Because if you don't think this is a problem, then you don't care about SRM. I would think that most people do actually understand that this is a huge problem, because it would seem here that we have two groups that were assigned to an experiment where we draw a conclusion that is obviously mistaken. And if this happens in practice in our own experiments online, we would definitely want to know about it so that we can take the right decision. But how will we know that this has actually happened? So let me get to next step. How can we actually detect that this sample ratio mismatch has happened? And let me first explain what we mean by a sample ratio mismatch. The mismatch is that we expected a particular ratio between the samples in control and treatment, and that expected sample is different from the observed sample. Let me give you an example in numbers. This is my own little toy calculator that I use every once in a while. Imagine that you had an experiment that you wanted to split 50-50. So you have about 10,000 visitors coming to your website, and your intent was to run a normal A/B trial where you split the traffic 50-50. And imagine further that what you observe is that in A, there are about 900 people, and in B, there are about 9,100 people in total at 10,000. That would be unexpected, I think. We would expect to see approximately 50-50, not something that is heavily skewed towards one side. And so this is what we would call a sample ratio mismatch. There is a mismatch between the expected proportion and the observed proportion. And you can see that the tool also warns you that this is the case in the yellow warning. It gets a little bit more difficult if you pick numbers that are closer together, right? If we use, say, 9,986 versus 10,056, then it's not immediately obvious whether that difference is big enough for us to say there is a sample ratio mismatch. Clearly, we will never, we're not always going to get an exact split between A and B, right? We expect some variation between the traffic, but it's difficult to decide when something is problematic and when something is not. If you flip to the next one, 9,874 versus 10,270, that's starting to sound a little bit more concerning, maybe to some. At this point, I would ask the audience, do you think this is a problem, yes or no? But this is virtual. Luckily, we don't actually have to do this in our heads, right? Statistics has solved this problem for us, and what we can use is called a goodness of fit test. And goodness of fit test is a statistical test that tells us whether the observed proportions actually match the model that of the expected proportions. And LinkedIn, I can share a link to this paper later as well. But LinkedIn actually has a paper about doing this in an automated fashion. It's called Automated Detection and Diagnosis of Biased Online Experiments. It's fairly simple to automate. If we go back to the, I know I say back, but Kelly, my
mean
slides
forward.
actually have the backslide in it. So for you, that means forward. I know it's confusing.
No worries.
So if you go forward, Kelly, to the next slide, you'll see that that proportion I showed you earlier of 9,874 versus 10,270 actually does not give us a very, very significant p. Oh, it gives us a significant p-value actually. At the bottom, it gives you in very small numbers. It says that there's no indication of sample ratio mismatch. P-value equals 0.0053. That's because I use a very high threshold to detect. If we were using, I don't know, 0.01, then it would actually detect. If I tweak those numbers a little bit and I move a few people over to the B group, then it will actually start warning. If you go to the next. Yeah, so then it says, and now it's over the line, and we say there's an SRM. So this is a statistical test that gives us a p-value just like a normal A/B test would, except instead of testing whether there's any difference between A and B, we're testing whether A and B are well proportioned, or at least proportioned the way we expect them to do. If you wanted to do this in Python, there's actually it's a two-liner because you actually have to import the library first, and then it's a one-liner where you use a method called binom test. This is one way to do it. I'm sure Matt on the call has a billion ways to do this, and I'm probably doing it wrong, but this one works. I'm aware of only 2 commercially available SRM platforms that actually actively check and warn about SRM. And I'm not counting my own. So within Booking, our platform has been warning users about this for years now. And we find lots of different sources of this error. We try to help people diagnose why it happens. Microsoft does the same. But in the commercial space where you buy an off-the-shelf tool, I'm only aware of 2. I won't name them. That wouldn't be nice. Let me try and I'll go on my. So Matt, if you want to know if Conductrix does the SRM test, then you should ask Matt. I'm pretty sure they do. That's actually one of the 2. See, I said it now. Who suffers from SRM? So now that I've hopefully convinced you that this is a problem and that it's actually relatively easy to detect. You notice that when I showed you how to do this test, the only numbers that I needed were the number of Channing Benson mentions the other one. Yeah. So Split. Yeah, Split also does SRM testing. Yes, I know. I told them. So the only numbers that you need are the number of people, and the number of visitors in A and the number of visitors in B. You do not need access to any of the underlying data. You do not need to like, this is not a big data problem. Right? This is literally like 2 numbers that you punch into a calculator. So it's relatively straightforward to detect. And the next question would be, well, if it's straightforward to detect, who actually suffers from this problem? The paper I mentioned earlier by LinkedIn, Yaju and her team, automated detection of and diagnosing of biased online experiments, actually mentioned explicitly that at LinkedIn, about 10% of our triggered experiments used to suffer from bias. And the bias they mean here is SRM. So that's about 1 in 10 of experiments at LinkedIn who actively checks for SRM would have an SRM. If you go to the next slide, there's a paper from Microsoft where they also point out, also give some numbers on how often this happens at Microsoft. And they say that approximately 6% of experiments at Microsoft exhibit SRM. Other than that, I am not aware of anyone who has published any numbers on how prevalent this is in practice. I would love to get more data on other platforms, especially since I know that both LinkedIn and Microsoft are actively checking for SRM and trying to fix it. And so you can imagine that SRM can have many causes, and that if you repeatedly find an SRM, that you try to sort of fix those bugs so that doesn't happen again. And Microsoft and LinkedIn have been doing this for years. For those products that have not been checking for SRM, I have no idea how many SRM causing bugs they have because they haven't even checked. And so the percentage we have on the next slide is somewhere between 6 and 10% for companies that are leading in the field and that have been actively detecting and addressing these issues for the past years. I would argue that if companies are not checking for this yet, it's likely going to be higher, not lower. right? It would be quite weird if without checking, they wouldn't sort of avoid all of the problems that LinkedIn and Microsoft apparently have. So I think the inconvenient truth here, the hard to swallow pills, is that this is real. This is a real problem that exists, even if you're not checking. Right? So now that you know it's a problem and that it's easy to detect and that it's probably out there and your experiments might have it as well. So you might be inclined to start checking now and look at your experiments and check, do I have SRM? Once you find one, the obvious next question is why? Why does my experiment have an SRM? And so to sort of try and answer this question, Alexander Fabian at Microsoft and myself and a few others, we wrote a paper trying to give an overview, a taxonomy of potential reasons for SRM, because like I said at the beginning, SRM checking is not a silver bullet, right? It doesn't solve every data quality issues, but it does detect a wide variety of them. And there can be many different reasons why an SRM occurred. I realized while I was writing this paper, I was interviewing other companies that have their own A/B testing platform. And I realized I was spoiled at Booking because I only thought there was like 1 or 2 reasons that SRM could occur. And that's because we have a very mature platform where over the years we have solved many issues that cause SRM. But when I started talking to practitioners that are, running like bespoke Google Analytics queries that pipe into Google Sheets and then running their analysis, it turns out there's actually a lot of more reasons that SRM can occur that I had never thought of. And so we wrote this paper. The classic example that is in literature is from Microsoft. It's one of the fun ones where they had this experiment where they changed their carousel on the MSN homepage to have more pictures in it. Now, I'm not a big fan of carousels. Let me just say that front. But they thought it was a good idea, whatever. And so in the A condition, the carousel had a number of pictures in it. And in the B condition, it had a lot more pictures in it. So users were able to click through many, many more pictures. And what happened was that an SRM was flagged. The team started investigating. And very quickly, they realized that what was happening was that the bot detection mechanism that they have was flagging these users that were clicking more as bots. And because they don't want bots to pollute their experiment data, which makes sense, they were being removed from the experiment entirely. In other words, those users that were affected by this experiment, by increasing their engagement, were removing themselves from the experiment, which resulted in fewer people in the treatment condition, which resulted in the SRM. Now, obviously, similar to the weight loss example that I shared earlier, this is not what you want, right? In this case, we're accidentally excluding exactly those visitors that we're most interested in. So this is really, really, really bad when it comes to making decisions based on this data. So SRM saves the day here because it helps the team understand that there's an issue, investigate what was that the cause of that issue, and then remedy by ensuring that these bots that were actually humans were no longer excluded from the experiment. Now, this is one example of a cause that could result in an SRM when looking at experiment results. And on the next slide, I have our taxonomy that has actually 5 different categories of SRM causes in it. I've highlighted the middle cause, which is the experiment log processing, because that's where removal of bots falls under, right? This is how we process the logs that come from an experiment. But going from left to right, SRMs can occur when experiment assignment doesn't work correctly. For example, we are not bucketing or randomizing users correctly, or we're not running experiments in our orthogonal way, or there are interaction experiments between experiments, or we have carryover effects between different experiments. So all of these could lead to SRM, might not necessarily, but could lead to SRM. Then the second category from the left is experiment execution. And that breaks down into variants starting at different times. This is something I had never seen before, but when we started interviewing companies, apparently some companies start A before they start B. Now that could very quickly result in SRMs. But also delayed filter execution, where people are actually exposed to the experiment before they are included in the experiment. And then there's all these problems with telemetry generation, such as redirecting only some variants, which I also hear is quite common in some companies, or a telemetry being added or removed in a variant. Now, experiment log processing I talked about. Then the fourth category is experiment analysis. Something people like to do sometimes is look only at a slice of time of the experiment. So not the entire duration of the experiment, but look only at the last week. And that can result in SRM if the treatment is actually causing people to come back or more often or less often, because then that last week will have more or less visitors in it than you would expect if it was completely random. And then lastly is what I thought was the most interesting category, which is experiment interference. And we're not talking about outside interference only, right? This is not just people hacking your website and adding a lot of bots to the B variant, but there's also this concept of experiment interference by the experimenter themselves. So if you go 2 slides down, Kelly, my favorite example of this is is this Google? Yeah, Google. So I don't use these tools, so I'm sorry. But this is Google Optimize, where you can actually, while the experiment is running, you can change the proportion of people going into A to B. I have no idea how this works under the hood. And they actually explicitly say changing weights can affect data. Since changing variant weighting only affects visitors new to the experiment, it can affect your experiment results. And I would argue, yes, it can totally expect. In fact, it probably invalidates your experiment results depending on context or setting. And so this is something that would result in an SRM error as well. This is what we call experiment interference. So SRM is everywhere, and not just everywhere. There's lots of different reasons why it would occur. And so if you realize that this is a problem, and you start to test for it, and you find it, then root cause analysis, or trying to figure out what is the cause, can be difficult, right? It's not always straightforward to understand why SRM is a problem in your experiment. And so lastly, I want to touch a little bit on what is it that we can actually do. What is this one neat trick that I promised at the beginning? And really, I have lots and lots of questions here, right? I think the one neat trick is that you check for SRM. Then step 2 is fix whatever is the problem, and then you get more reliable results. That the SRM is only the canary in the coal mine. It doesn't actually tell you how to solve the problem. It can only tell you that the problem has occurred. Now, to try and make life a little bit easier for people, I have been working on a plugin for Chrome that actually adds SRM checking automatically to platforms that don't yet support it. As I said, the only thing we really need to do an SRM check is the counts for the number of people in each condition. And that is often shown on experiment reports. And so it's fairly easy to scrape the web page and just add SRM checks to platforms that already exist. And so we have this Chrome extension that you can download so that you don't have to do the calculation manually. You can still do it manually on this site as well, but the Chrome extension is just a handy way to do it. On the next slide, you can see what that looks like in Google Optimize, but we support a bunch of other platforms. A big shout out to Georgi Georgiev, who actually added the support for most of the platforms that we have. I didn't actually have access to these tools, so he was the one who wrote the plugins for each individual platform. And so here you can see that we have an experiment that's supposed to be 50-50, but we have 615 sessions in original and then 440 sessions in treatment or experiment. And that's not what we would expect in a normal 50-50 split. And so these numbers are then colored red and flagged as a potential SRM. All of this is on GitHub. So if you don't trust me to write like good software, then by all means, patch is welcome. Join us. The more the merrier. Yeah, I think it's MIT licensed. So if you want to use it in your own platform, then go ahead. Then in the paper, we also have some rules of thumb for doing the actual root cause analysis, because again, the detection is easy, but then finding out what is actually the cause of the SRM is often a lot harder. So we made 10 rules of thumb that would hopefully help people, because really, like the picture on the right is very, very much the reality, right? If your experiment has SRM, I'm sorry for you. Full stop. Finding out what is the problem is the hard bit. But examine, if your tool supports it, examine different scorecards, right? So if you have different breakdowns for users, or different user segments or different time segments, look at these. Often performance issues on the web can be a problem. Often engagement metrics can be a problem. Count the frequency of SRMs is a way of saying if it happens a lot, it's probably a problem with the platform, not with the experiment. And I forgot to mention, but sometimes an SRM can be caused by something that is inherent to the experiment. So it could be, for example, in the bots example that Microsoft gave, right? This is something that is caused by experiment itself. But sometimes it can be inherent to the platform. So one of the causes is that the coin flip is broken or that the randomization doesn't work. That's something that's inherent to the platform. So 6 and 7, counting the frequency and looking at AAs are ways of trying to figure out, is this something that is specific to particular experiments, or is this something that is just across the platform problematic? Examining the severity of the SRM often gives you a hint. Downstream dependencies and across could also help. And 10 is something that is specific to Booker.com. Our architecture actually has 2 independent pipelines for data processing, partially for redundancy reasons. So we want to be able to get data even though one of the pipelines might be down because it's so critical to our business. But the other is that they actually use different code and technology under the hood, so that if there's a bug in one, it won't affect the other. So we can cross-check. And that often gives us a sense of where the SRM is, because if one of the pipelines has SRM and the other does not, then it's something in the pipeline. If both of them have SRM, then it's something in telemetry generation upstream. Bunch of links in the slides for the Chrome extension, the GitHub project, and the taxonomy paper. If you have any questions, I'd be happy to take them, but I'm also available online if you want. So that's it. No, that's my bonus slide.
Come on.
Don't spoil the bonus slide. This is a question. So this is a question I get a lot. People say we use a Bayesian methodology, so we don't need to check for SRM. But actually, the assumptions that go into most Bayesian models are equally violated if you have an SRM. So that doesn't work. Right? Bayesian doesn't correct for these sort of fundamental data quality issues.
Wah, wah, wah. Okay.
Sorry.
You're good. You're good. Sorry, I spoiled your. That's my favorite slide though.
The other one I get a lot related to the Bayesian is we use bandits. Can we check for or machine learning or these platforms that change the assignment of visitors to a particular variation? Yep. Can we still check for SRM? And I think theoretically it might be possible, but not just with the raw counts. So not with the same numbers, right? You would need more information about how that assignment actually works. Yep. In order to be able to check for SRM. So there, you can't use this canary in the coal mine to check for these data quality issues, which means you have to trust the platform more than if you were able to do SRM checks.
So Valerie asks, I'm sorry, I can't believe I just called you Valerie. Val asks, you need to change your name to Val on the thing. How soon after you launch your test can you run the check? Oh. Because obviously, a lot of us have the SRM check embedded in like a analysis workspace in Adobe or a Google Analytics.
Yeah, so that's a good question actually. So so often what happens if you find an SRM is their common cause is that there's some kink that is causing missing data. Mm-hmm. And very often that means it's impossible to recover from that problem. Even if you fix it, the only solution would be to reset and rerun the test. Right. And that means that if you wait until the very end of the experiment, then that's going to be very painful. Because it means basically you have to chuck everything out and start from scratch. So ideally, you would detect that SRM as soon as possible so that you can stop the test, figure out what's going on, and restart with as little delay as possible. So that's what we want. the SRM check itself is a statistical test that, very similar to the significance test, has to deal with power. That is, the more traffic you have, the smaller the difference that you can detect. So if the SRM is very severe, then you would find it very quickly. If the SRM is subtle, it might take a very long time to detect. And so even if we start checking very early, we might not detect the SRM until very late in the experiment. But if it is severe, it's still valuable to start testing very early. Then obviously the next question is, yeah, but that means I'll be testing every day or maybe every hour or every time I look at the report. And don't we run into repeated testing problems, right? Don't we increase our false positive rate? If we repeatedly check, we're essentially peaking at a statistical test, and that is true, right? And so if you check for SRM every single time when you look at your experiment, you increase the risk of having a false positive on your SRM check, right? So wrongly concluding that there is an SRM. And that is exactly the reason why in the examples that I showed you, the manual testing calculator that I have, I actually used a very high threshold because I wanted to make sure that even with repeated testing, the odds of a false positive were very low. There's also a new method that Optimizely, I believe, has put on GitHub. Oh, it's actually shared on the chat now. So Optimizely is releasing a white paper with what they call SRM, and it's a sequential SRM test, which allows you to continuously monitor without an increased false positive rate. I haven't actually looked at this implementation itself. Conceptually, the idea makes sense. You want to be able to repeatedly test for SRM, and sequential testing is one way to allow for repeated testing, but I don't know anything about this particular method. I also don't know whether Optimizely is actually using it in their product. That would be very interesting to know, right? Because Optimizely is obviously used by a lot of people. I want everyone to check for SRM. So if Optimizely were using this in their product, that'd be awesome. But I don't know if they use it. Does that answer your question, Val?
Yes, thank you.
Awesome.
Her second question, do you have any advice on how to implement for testing in other channels like media, direct mail, or SMS?
On how to implement for testing in other channels.
Implement SRM.
I don't get it.
SRM checks. Where you're doing like offline.
Oh, but in those channels, yeah, you're doing the same A/B testing there, right? Is that the question?
Yeah. Correct.
Okay, you won't be able to use the plugin, but you can still use the manual calculator that's on the website. So on the lukasvermeer.nl/SRM, there's a link for manually checking for SRM. You can just use that. It will tell you whether there's an SRM or not. Or you can use the Python that I shared. Or roll your own. I mean, look, this is a very simple statistical test, right? So just put in it. I think Veronica Have actually shares an Excel sheet that does it.
Yeah.
So if you like Excel, then I guess you can use that.
Okay. You mentioned non-orthogonal tests can cause SRMs. Can you explain why that increases your SRM risk? And for those who aren't aware, can you explain what you mean by non-orthogonal?
Okay, so orthogonality is if you're running two tests, then in order to analyze those tests independently, you need the coin flips or need the assignment to be independent. In other words, if I'm a user and I end up in B of one experiment, that should not change my probability to get in either A or B of the other experiment.
And
so there's no information.
The platform you're using is using orthogonal designation.
Yeah, so theoretically, if they're using a proper randomization function or a hashing function, then that's the case. I have actually talked to companies where their randomization function, instead of proper randomization, would use something like, I don't know, the last number in the user ID as a way to decide whether a user goes into treatment or control. In that case, everyone is either in treatment or in control for all tests. And clearly that's not orthogonal. And that means that if you're running two experiments at the same time, the results of one can contaminate the other. For SRM, this means that if one experiment is causing people to leave or to exhibit a particular type of behavior that makes it less likely that they're actually tracked or properly measured in the other experiment, then this would lead to an SRM in the other experiment. I have to say, I didn't add that one. The Microsoft people that wrote the paper or that co-authored the paper with me added that one, and they said they've seen it. I have not encountered that myself in practice.
Okay. ITP. As ITP in different browser changes occur because of the privacy changes, how likely is that to have an impact on SRM?
Oof.
It feels like as long as you have that random sampling, you should have the same impact in control versus challenger. But if your challenger is using information that is going to be blocked, maybe that's a scenario.
So no, so this can happen, but there's actually the problem is then not ITP is something deeper. So I've seen this in before where so imagine that we are correctly randomly sampling. So a user hits the site, we put them in base invariant. However, our measurement or telemetry for tracking those users has a failure rate. So not every time we are able to capture the user, right? Only if they come back repeatedly.
Mm-hmm.
Now I can imagine ITP makes people come. No, they still look. They would still be randomly assigned, right?
They'd be randomly assigned, but
yeah, I'm halfway through my explanation, and I'm like, no.
Well, no. It would inflate your visitor counts because for the people who
but they would be inflated on both sides, right?
No, but if one increases the number of visits per visitor, then that one will actually look like it has more visitors than it really does, and the control wouldn't.
Yeah, but is that because of ITP? That's because of the data loss, right?
The ITP blocking that makes a return visitor look like a new visitor. So that one's confusing, guys. We'll all noodle on that.
I'm not sure. So I mean, so from my point of view, like I mean, the problem with these things is that the reasons for SRM to occur are often quite simple and very technical, right?
Yeah.
And so SRM is this great canary in the coal mine that says there is a problem, but it doesn't necessarily answer the question of what is the problem. And that's why I wrote the paper to say, like, well, there's tons of reasons this can happen. And one of the reasons I made the website and put it on GitHub is that I assume that my list is incomplete. And the list that's on GitHub is actually longer than the one that's in the paper. There's more reasons on GitHub than are in the original paper because we found a few more between publishing it, between writing the GitHub website. And so if you find a reason that ITP is a cause for SRM, then I would absolutely please do add that to the GitHub page so that more people can learn about this. It's fairly easy. It's a markdown, so you can very easily add things to that website with no coding skills whatsoever. I would guess if ITP would probably fall under experiment assignment or execution in terms of the taxonomy. That's good question. Makes me think.
Yeah,
I like those.
We've got two more in the Slack so far. First, Freya asks if the experiment has already completed and you find SRM errors, are there any options at this point to basically be able to still use your data, minimize the bias that it
please, Lucas, please don't tell me you throw away my data.
Right.
That's what you're asking, right? Can I please save my experiment? So the answer is it depends. And it depends on the cause. So if the cause is, I don't know, truly missing at random, right? So truly some users in the treatment fell out and had nothing to do with the treatment whatsoever, and you absolutely know for sure that that's the case, then yeah, you could still use your data. But you would have to understand what the reason is to know whether you can trust the results still. I've seen an example, this is a really ridiculous example, where to do A and B assignment, they were picking a random number between 0 and 1. and then to decide whether it was A or B, they were saying greater than 0.5, and it should have been greater than or equal to 0.5. Otherwise, you don't get exactly 50-50 split. You get this sort of somewhat biased split. Now, obviously, you only find this when you have like billions of visitors in your experiment. But that then was flagged as an SRM because it wasn't 50-50 split. But that particular bug, it doesn't actually create bias in the results. So we could still use the results of that experiment. So it's possible, but only if you really understand the cause of the SRM and you are certain that there is only one cause of the SRM. Because that's the other thing, right? Even if you find a cause of the
Not be the only one.
it might not be the only cause. And so can we still use the data after SRM issues are detected? Yes, but only if you find a cause, you correct for the cause, and then you make the assumption that there is only one cause.
I like it. Stephen is asking, how does unequal A versus B assignment ratio? Oh, yeah. I was going to ask that as well. Does your calculator automatically assume equal splits? Or
you can change it.
Okay.
So in the, if you can open it up and just go to Kelly, go to lukasvermeer.nl/SRM. So a sample ratio mismatch. You type, I talk.
Vermeer.
My name.nl Netherlands. I'm Dutch. Hi. And then click on the manual calculation.
Oh, that wasn't it.
No.
Lukas Vermeer. Oh, yeah, I did.
There's double E in the end, yeah.
Sorry.
And then click on the manually check for SRM. So as you can see, this calculator allows you to put in numbers, and then the second column is actually the expected proportion. So SRM says the proportion is different from what we expect. It does not say that we should expect 50-50, because what we expect depends on what we set up. And so in the Chrome extension, one of the things we do in the background is we actually load, in the optimizely case, we load the settings for the experiment to figure out whether it's actually set to 50-50 or something else, because we need to know what is the expected proportion before we can actually do the SRM test. So it does not have to be equally assigned for us to be able to do an SRM check. Now, the second part of this question is auto optimization experiment. So that's the bandit case that I talked about before, where if the platform is changing the assignment along the way, and so it's not fixed, then no, you cannot run an SRM, because the SRM test assumes that the proportion is fixed from the start of the experiment and does not change. Right. And if you want to be able to, I spent some time thinking about, like, if we have this adaptive mechanism, what data would you need to collect in order to be able to do an SRM check in that case? And I think you would need to know a complete time series of when the expected proportions changed and to what. So any time the platform would change the proportion for the entire duration of the experiment, we need to know that it changed. And that might not even be sufficient if we have missing data issues. Matt says you could use propensity matching. Yes, but you would need to know the propensities match, Matt. Yeah, so you need additional data in order to be able to do it in that case, and it's not as straightforward. So it doesn't, like, the reason I don't mention it is because it's no longer one neat trick. It becomes a very difficult statistical operation at that point. So it's no longer, it does fit the one neat trick paradigm anymore.
Yeah. My questions moved. Here we go. Do you check SRM for your subgroups for the segments? So for example, if we use your eyeliner example, more males may have dropped out of the experiment with the eyeliner question variant, but maybe more females dropped out of the aftershave question variant. So if you only looked at the top level, it may appear to have equal samples. Sizes. Not equal samples, equal sample sizes.
Yeah, the totals are the same. Yeah, so that all right off the bat, that is super unlikely though, right? Like the odds of that happening are super unlikely, but it could. And so at Booking, we do check different segments for SRM as well. Again, you want to increase your p-value threshold there because decrease the p, because you don't want to have too many false positives there. But it's an excellent bug hunting mechanism, right? Because as soon as you find an SRM at the top level, or even if you don't, when you dive into, say, browser segments,
to figure
It
out.
might be very interesting to know that Firefox number 49 actually has SRM. So yeah, definitely look at segments specifically for technical data issues. It's very useful.
Similar for when we're doing our, our regular experiment checks, and unequal sample sizes or small sample sizes impact our ability to see the signal. If we're checking for SRM earlier, you mentioned obviously the earlier it is, less data you have, you still have power that you have to consider. In a scenario where you have unequal sample sizes, say you're doing a 80-10-10 or a 10-90, whatever, is that going to impact your ability to see a sample ratio mismatch error early? And if you slice and dice it along the way, is that also, do you just need more power?
So the first, I think an unequal split, you will, Matt, please correct me if I'm wrong, but I think you actually will have less power for an SRM check. I think.
It should be, because the power is dependent upon the
smallest group.
Yep.
And for the segment case, yeah, for Matt says, And so for the segment example, right? Every segment is a smaller audience, so yes, you will have less power to detect SRM on the smaller segment. But I think in the bug example, right, when there's a bug with a particular browser, it's often quite drastic for a particular browser. So the effect size is much larger than it is on the global level. So you don't have much of a power issue there.
Yeah. We have
actually, I heard a rumor that Microsoft is working on some automated SRM investigation tools for their EXP platform. So when an SRM occurs, they automatically check all the segments, and then they tell the user, hey, it looks like you have a problem in this browser, which sounds like, to me, it looks like you're saving a user 2 clicks, but it might be useful to sort of give these proactive advice to users.
For sure. We have 1 minute left. I'm going to ask Val's question, and then I will wrap up all the questions that were sent to me into an email and send them to you, Lukas.
Please do, yeah.
I've got time to answer them. So Val's question is that you quoted 6 to 10% prevalence from the Microsoft and LinkedIn studies. Assuming that's an average, do you have a gut for where programs can and should set their goal for how often they should see, if they're addressing it and being proactive? How often should they expect to see it?
It's a good question, Val. I have no idea.
Yeah.
So, like never would be a good
goal.
Yeah, I mean, and again, like how severe this is really depends on what is the cause of the SRM. SRM is really only a mechanism to detect. And so if you have it, if you start checking for this and you have it 90% of the time, but it's an innocuous reason, then maybe you don't care. If you have it 90% of the time and it turns out, you're removing bots from experiments only for the B variant, then that would be bad. So yeah.
All right. Thank you so very much, Lukas. Really appreciate it. With your permission, can I send the PDF of your presentation to the?
Yeah, sure.
Okay. And of course, the recording. Okay. I'll let you confirm. But the recording will be on YouTube, and I will also send you, Lukas, a list of the questions that were asked with the answers that we got today and those that we didn't get to. So if you have time to answer those, I'll send those out to the TLC group.
Can I make one request to the group? If you find an SRM and the cause is not on my list, tell me. Because like my goal at this point is just collect. I'm a butterfly clicker, right? I want to collect all the different reasons that SRM can occur. So if you find it, tell me about it, and I'll add it to the list.
That seems.
Or you could add it. It's open source, so whatever you want.
Awesome. Thank you, Lukas. Thank you, everybody. Until next.
Cheers. Thanks for having me.
Absolutely. Bye-bye.
Bye.